Okay, so as soon as everybody settles down, we can start. So hello everybody, welcome to this week's Tech Talk. It's going to be about enterprise architecture and Spring Cloud services. So we actually started this series of Tech Talks about 4 years ago. I think it was in 2016. I came back from a spring conference and I wanted to share the knowledge that I learned in that conference with the students. So we started this series of Tech Talks. So every block, one of the faculty comes here and then talks about one area of computer science. So for example, this is my area of specialty, enterprise architecture, and basically a Spring, cloud services, microservices. So I'm going to give a talk about this area. But every block, one of the faculty or one expert in the area, not necessarily the faculty, comes here and gives a tech talk. One of the things that I want to encourage you to do is, if anybody is interested in, giving a tech talk in any area, you can come and talk to us, and we can arrange that for you. So this is my name. I'm an associate professor of computer science at MIU. Just a month ago, I was doing some consulting for a company in the Chicago, Milwaukee area called Uline.com. So I just came back to teaching from 2 years of consulting for that company. This is me. This is who I am. I have an undergraduate degree in electrical engineering, a master's in computer science. I have over 25 years of software development experience, mainly core Java, OOA analysis and design, Spring, Hibernate, microservices, RESTful web services. So these are all my areas of specialty. In particular, what I have been doing for the past 10 years mostly has been designing RESTful web applications using Spring, Spring Boot, Spring Cloud Services, and Hibernate. So that's what I've been doing in the past 10 years mostly. Today we are going to talk about two main topics. We are going to look at enterprise architecture in general, and enterprise architecture is a large area, right? It's not just a simple topic that we can cover in about an hour or under an hour, but we are going to look at some main points about building a larger scale software system. We're going to see what is involved in building a larger scale, a scalable, maintainable, large software system. And in doing so, we are going to look at the Spring Cloud services, because nowadays the trend is obviously running everything in the cloud. And when you start running things in the cloud and you have microservices architecture, then things can get easily very complicated. And to manage that complexity, you need obviously frameworks and systems to manage that. And Spring Cloud services helps in that area. Plus, the Spring Cloud Services implements a lot of good architectural design patterns. Namely, service registry is one of them, as an example. Another one is a circuit breaker. Another one, service discovery. Another one is configurations in the cloud. All of those are good architectural design patterns that are implemented by Spring Cloud Services. So let's talk a little bit about enterprise architecture. I'm going to give you a very simple definition of enterprise architecture. This is my simple definition of enterprise architecture. The art of building larger scale, high availability, high volume, maintainable software systems. So this is basically what enterprise architecture is about. I'm going to show you two of my favorite quotes from Rod Johnson. Rod Johnson is a champion developer. And for those of you who don't know Rod Johnson, he's the one who actually created the Spring framework back in the early 2000s. I think it was 2002. He actually wrote a book. It was a fairly elaborate book. At the time, the alternative for writing enterprise software was mainly Java, EE, and EJBs. But for those of you who have used EJB, it's a complicated architecture. I have to tell you that this is probably one of my least favorite things that the Java community has done is EJBs. I often tell my students that I hate it with a passion. EJBs are complex, and in my opinion, just extra complexity for nothing. Well, you do get some functionality out of it, obviously, but it's not my favorite. So this quote, Rod Johnson talks about simplicity versus complexity. I'm going to read it to you, and I'm going to pay attention to the topic of simplicity versus complexity. So developers tend to think that because complex technologies like EJB exist, they ought to use them, whether it's really necessary or not. Good engineering practice doesn't mean using the most complex approach. The more complex an application is, the longer it takes to develop, the harder it is to maintain, and the worse it's likely to perform, right? So what he's doing here is basically promoting simplicity. Simplicity is not a bad thing. Simplicity is actually a good thing. So then he goes on to say, my advice to developers is, read the Gang of Four patterns book from cover to cover at least once a year. This contains 90% of what you need to know about patterns and is guaranteed to make you a better OO programmer every time you read it. Okay? So he is basically pointing you in two different directions. One is basically simplicity. Do not necessarily over-engineer, design your system. Do not make it too complex. Simplicity is actually a good thing. And second of all, learn your design patterns. Design patterns are extremely useful in creating extensible, scalable systems. So these are his two recommendations. I want to show you a video which talks about the cycle of code. This is from one of the conferences that I attended a few years ago. I think it's from one of the Spring One conferences. And talks about the cycle of code. And the reason I want to show it to you is that, if you're developing just a small application, yes, I mean, a team of 1 or 2 or 3 or maybe 5 people can do it, and you barely, maybe you don't need necessarily any methodology, you can get away with it, that's okay. But as soon as you want to develop something for an enterprise, you're basically designing an enterprise application, then you need to follow some best practices. Then you need to follow some methodology. And I think this video actually talks about that in detail. So we're going to watch a few minutes of it. We're not going to finish the whole video, which is about 20 minutes.
Hi everyone. It's great to be able to kick off the last hour of the conference. This last hour is all spring. We've got a great code demo coming up. But right now it's me. What I'm going to do is take you back 45 minutes or so to Auntie's presentation and the circle of code. So just to recap, the circle of code is this. All software starts with ideas. Ideas are recorded, logged in a software system like Tracker. You then take that and develop software, hopefully using Spring. As you commit code, it's built continuously, perhaps using a CI system, perhaps Concourse. In Concourse, you deploy, perhaps to a platform, hopefully to Pivotal Cloud Foundry. And then, as a result of running software, you can analyze it, you can look at metrics, and that gives you more ideas. This is circle of code. Easy if you're working on a small system, as we've heard, a bit harder if you're working on a monolith. Now, the interesting thing about the circle is, once you know about the circle, once you know about this idea of feedback loops, you kind of see them everywhere. So what I want to do is take you through some history. I want to talk about Spring from its inception. You can analyze it, you can look at metrics, and that gives you more ideas.
Okay, so I mean, I can share the link and you can watch the video on your own. I'm not going to play the whole video for you. My main intention was basically to point out the circle of code, right? So the code always starts with an idea, and usually in, let's say, an agile system, you document that in the form of, stories and then feature stories in some sort of a task management system. TFS is one good example. Jira is one good example. And there are many good examples of task management systems. And then you basically, once you have all the code, all the requirement, then you can use, some design methodology, some framework to develop your code. And then you have your continuous integration, CI/CD, continuous integration, and a continuous deployment. And probably if you're working for a modern shop, you're going to be deploying to cloud all the time, not your just local servers. And then you have some big data, maybe some metrics, some feedback from your customers, and then that feedback is going to result on more ideas, and those more ideas are going to be deployed. And the whole idea is that the faster you can go through this cycle, the better. Okay? So these days, software companies need to be very competitive. And to be competitive, you need to be performant. You need to be able to do things fast. And imagine you're dealing with an enterprise application. It's already super complex, super big, and you need to be able to basically run through it really fast. The last company that I worked for, our sprint was 3 weeks. So in 3 weeks, every 3 weeks, we would take features to production. So we would start by planning for the sprint even before the sprint. As the enterprise architect, I was there to help them plan for the sprint. And then a sprint starts, we assign tasks to developers, and developers start developing, and then take it to dev environment. They test it there, then QAs start testing it. And by the end of 3 weeks, our code was in production. So that's a very fast pace. And the only way you can go so fast through releasing code is through using some methodology, which I am going to discuss in the next few slides, and was also given in this in his presentation. So here are some of the things that are used in an enterprise environment and are parts of continuous integration, continuous deployment, right? So number one, you need a source control management tool, such as Git, CVS, CS, etc. And the reason you need that is, your developers are going to be sharing a common source code, and as a part of that, basically they check out the source code. Everybody's sharing the same source code. The source code is basically stored in a server environment, not on developers' laptops, and then you check in as frequently as possible. The other part of it is automated build tools, such as Maven, Gradle, Jenkins, etc. So you basically want to automate your whole build and dependency management system so that it's efficient, so that it can be done automatically, such as Jenkins is actually a build server. So in a lot of shops, the way you do it is that you basically check out the main branch, then you create your own branch off of the main branch. You do your development, and then as often as many times a day, you can check in your code. And every time you check in your code, that triggers a build on the build server. And the build server is going to run through your code, basically build it for you, then run unit tests, then run quality tests, and then all sorts of automation that is going on in that area. One of the things that these days is actually very popular is software quality and code coverage. And that is automatic. It's not code coverage by, well, there are two types of quality assurance. One of them is code review, right? So again, in my previous company, every single line of code needed to pass through an approval process. And at least 2 people needed to approve that. One was the architect, and one was another developer on the team. So for the past 6 months of, last 6 months of 2019, I did write some code, but most of the time I was basically, as the architect, I was reviewing other people's code and trying to see what they're doing. If I have any feedback, I would provide that, and they would go fix it, and then the code would come back and then ultimately get approved and go through the process. On top of that, you have tools such as SonarQube, Covertura, and then actually this is JTest. This JMeter is wrong. JMeter is for performance testing. JTest and other tools that help you, but basically it doesn't run your code. It just looks at your source code, the static source code, and finds issues with your code, and then reports it back to you. Says, okay, for example, this style of programming is not exactly good, is not recommended, changing to this style of code. So that is software quality. Then you have some artifact repository, such as Sonatype, Nexus, or Artifactory. Those are just examples. There may be more in the market. And the idea is every time that you create something, so for example, the software that you write in Java, for example, is either a jar file or a var file. In the old days, in the monolith days, we also had EAR files. Nowadays, barely anybody writes EAR files. It's mostly either var or jar. So you basically store your jars or vars inside your artifact repository so that they are shareable. So other projects can use the code that you're writing for your project. So basically, you're sharing your work so that it can be shared and managed better. Then you have deployment tools, such as Urban Code, Kubernetes, and so on. So this is about automatic deployment, right? So in the old days, I remember I was doing some development, let's say 15 years ago. I would develop my code. There may or may not have been a source control, and then the result, imagine, is a var file. I just drop the var file manually in my Tomcat server, and obviously Tomcat absorbs it and deploys it and runs it. All of the whole process was manual. In a real enterprise workshop, you cannot do that. Okay. Well, first of all, that's super dangerous, because if you give your developers access to drop code in a production environment, that poses a danger and a risk to your environment. And on top of that, it's good to have some process, some organization to this whole thing. So a deployment tool comes handy. And then automated integration testing is another thing that we're going to talk about. So I'm going to talk about all these topics in just a few minutes. So source control management. This is a real example from my previous work. This is a microservice that I developed. It's an address validation service, and as you can see, this is a Git repository, and it shows the last however many commits that we have had. At this point, we fixed some Sonar issues, we fixed some unit tests, we improved the timeout issue, and so on and so on. And by the way, it's best practice that every time that you check in code into your repository, you leave some meaningful comment. So anybody who looks at the timeline of the changes of your code, they can see, okay, at this point, this change was introduced. And if that change potentially is impacting another area by mistake, that would, this description makes it a little bit useful to understand that. This is an example of Jenkins. This is Jenkins, for those of you who haven't seen that. And Jenkins can be used in many different ways. This is how my company was using it, uline.com. And I look at how the process works. It's basically a pipeline, and it has many steps. The first step is that it basically checks out the code from the repository. And as you can see, it's super fast. Then it does some preparations. Then it starts building and running the unit tests. So it's going to do a Maven install on your code, which also includes running all the unit tests. And then if this passes, and imagine at the end of each one of these stages, there's a gateway. So if one stage doesn't pass, it's not going to go through the rest of the steps. It's not going to waste any time. It's going to stop there. It's going to block it right there. So if the build and unit test passes, then it goes to the next stage, which is running it through SonarQube analysis. And again, SonarQube is for software quality. It's going to measure the quality of your software. If it passes the minimum quality that Sonar expects, then it goes to the next one, which is deploying the artifact, which in this case, again, could be a jar file or a var file, to your repository management tool, which could be Sonatype, Nexus, or Artifactory, or you name it. Then you see, this is a continuous integration, continuous deployment, right? So as soon as you check in code, just the fact that you have checked in code into a Git repository, it triggers a build here. And then as soon as the build finishes and passes all the quality requirements, then it deploys to Artifactory, and then it's actually deployed to a server. It doesn't deploy to production. Deploying automatically to production is never recommended and is actually dangerous, but it deploys to a test environment. Okay, and from that test environment, then it can be promoted to other test environments and ultimately to production. After it's deployed to the production, after the deployment finishes, and again, you see just the fact that we have under the cover, we have a deployment tool helps, because then Jenkins can call the tool to automatically deploy to a production environment. All of this is automated. No human interaction is required in any of this. Then after it finishes deployment and the code is ready in that test environment, then we start running some integration tests, some smoke tests, just to make sure that everything is actually working fine, everything is okay. And once everything is okay, we send out an email and notify a group of stakeholders or interested parties that, okay, everything was successful. Or if there is a problem, we send an email and say, okay, there was a problem, the build failed, and you have to go back and fix it. So this is the whole idea of continuous integration, continuous deployment. Now, a little bit about SonarQube. This is actually an actual screenshot from SonarQube, one SonarQube page. Right? So in this case, this project it says passed, which means, okay, basically SonarQube considers it meeting the minimum requirements. But at the same time, you can see that, so for example, there is a bug here, and there are some vulnerabilities. There are 147 code smells. But again, these are minor issues. And depending, you can configure the system however you want to configure it. But in this case, we have configured the system so that for minor vulnerabilities, it just lets it pass. It's okay. You can never get it to be perfect. And then the other thing is that code coverage. Code coverage means how much of your code does your unit test cover, right? And for those of you who have written unit tests, you know that, writing a unit test for, just the main flow of your application is easy. But then getting your unit test to force your code to go through all the if-elses and all the, exceptions that your code might throw. You see that there are a whole bunch of conditional and exception logic that may exist in your use case flow, that those are not easy exactly to replicate. So depending on how much you succeed in covering your code, then your percentage is higher. For my team, our requirement was that our code had to be 80% or better coverage, and that's a norm in the industry. I would say I have worked for many companies that have that 80% as the target. It actually has a lot of nice features. So, for example, it says the last person that checked in code had 90% coverage on the code that was checked in. 80% is basically overall coverage of the code. And then talks about code duplication. As you can see, it's even less than 1% code duplication in this thing. Code duplication is obviously bad, but here, as you can see, we are doing a good job. This is Urban Code. Urban Code is an IBM tool. It's for code deployment, and as you can see, at any moment of time, using a web-based, browser-based, view, you can look at the status of things. In this case, for this company, we had four major environments. Dev is any time that you build, Jenkins was deploying to dev, and dev is where developers are doing their testing. Once developers basically finish a feature, they test it on their laptop, they check it in, they take it to dev, they test it in dev, and everything is working, they promote that code to SIS, which is System Integration Testing. So then System Integration Testing happens in this environment, and once this is done, usually QAs work in this area. Then once the QAs approve the code and say, okay, this is working fine, then we take it to UAT, which is User Acceptance Testing Environment. So at this point, the end users of the application, which are not necessarily QAs or developers, they may not have an extensive knowledge of software development, they're just end users, they test the code and they approve that the code is working based on the requirements. At that point, you're ready to take it to production. Usually, developers, easily take, promote code from there. Well, first of all, if you build anything in Jenkins, it automatically deploys to dev. And then from dev to sys, easily can be promoted. From sys to UAT can easily be promoted. From UAT to prod needs approval. So there's an approval process. You can schedule it, but usually a software development manager, somebody has to approve it for you. So the previous slides gave you a basic idea of how software is developed in a real shop. Now, the other thing that is actually very common these days and is used a lot in the industry is, having a microservices architecture versus the old monolithic architecture. In the old monolithic architecture, we had something like that. Everything was packaged inside the same, WAR file or EAR file, right? In case of Java development, and in other languages, similar things. And then your presentation layer, your business logic, data access layer, all was packaged inside one, big monolithic piece of code, and that would be deployed, and this was the monolithic architecture. Nowadays, people divide up the whole business into many small microservices. And that helps speed up the cycle of code. Remember that cycle? The only way you can achieve a good velocity of code development is through dividing the system into smaller components. Because if you have a massive, big piece of monolith, it's not going to be easy to achieve that. The other thing that is interesting about this slide is a concept that is, again, very popular these days, that is called bounded context. So as you can see, each microservice is in charge of one area of your data. So for example, in my previous company, I was working for the customer team. Customer team was obviously the core. It was an online sale, like Amazon type of thing. So customer obviously is the core of everything. But then we had a microservice for items. We had a microservice for orders. We had a microservice for warehouse. We had you see, each microservice was not only an area of functionality, but also an area of data. So you basically divide up your system into silos, into vertical silos, and each vertical silo is basically one area of your business, actually. It represents one area of your business. And then obviously microservices can talk to each other. Presentation layer can talk to many microservices to basically collect it. Even for one page, for displaying one page, you may have to talk to multiple microservices. Any questions so far? Yes? Well, we have an example of it here. Well, then this microservice can call this microservice. Yeah, it's completely normal. We don't have it in this picture, but it's a possibility. And that's exactly, it's actually a very good point, because then if this microservice needs data from this set, it should never go to the database and directly access that data. It should always jump to the microservice responsible for that area. Yes? Mm-hmm. Yes, it becomes a spaghetti, yes. 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 For those of you who have done MPP, I believe in MPP we talk about subsystem design. In software engineering, we particularly talk about subsystem design. So all those good principles of subsystem design apply to microservices. So it's good. You see, microservices is good, but then just like you said, things can easily get out of hand, because then you have coupling. Then you have a lot of interconnections between different microservices. And to have some organization, just like you said, you can have some high-level services that work with a number of microservices, and they form a subsystem. And anyways, there's a whole bunch of design decisions. Architecture goes behind all of this, obviously, which I'm skipping. I'm simplifying things here for you so that we just go through this. Okay, so the next section of my talk is about Spring Cloud Services, right? Like I said, Spring Cloud Services provides techniques such as service discovery, centralized configuration, graceful degradation of behavior through circuit breakers, right? So it implements a lot of good common enterprise design patterns, incorporates a lot of them into this infrastructure that Spring provides, right? So as microservices became more and more popular, as more and more applications are running in the cloud, obviously it can easily become a zoo, as in it's completely unmanageable. So to manage that complexity, all these techniques come to help. And I'm going to explain some of them, and I'm going to demo some of them for you today. I'm going to talk, for example, about circuit breaker. I'm going to talk about service discovery, and probably configuration management a little bit today. So the roots of Spring Cloud Services are really can really be found in an open source framework developed by Netflix called Netflix OSS. So Netflix, as we know, is one of the largest, most complex cloud-based enterprise applications that exist in this entire world. You can imagine the level of complexity that Netflix has. Everything is in the cloud. And then, imagine that they have video streaming servers. And those video streaming servers, obviously, it's not just one or two servers. There are thousands upon thousands of servers that basically are supposed to cover the load that is required of them. And you can imagine that the massive amount of architecture that has to go into organizing these things so that they can actually work efficiently. And then you basically build a scalable system. So Netflix developers, developed a whole bunch of technology over the years. And then at some point, they decided to make it open source. So that, well, first of all, a lot of companies have the incentive to, it was proprietary code. They paid their developers to develop their code for them. But then they made it public. Can anybody guess why? Yes?
Yeah, when we make our framework as an open source,
yes.
There are many contributors, they work
correct.
on open source and they
Yep. Yep. Then you basically crowdsource it. Then what happens is that then you not only have your limited resources, limited number of developers working on them, but you get millions of potential developers in the whole world that look at your source code and they can point out issues and they can solve issues. They can solve issues for free for you, and then they can submit those issues. So they made it public. And Netflix OSS has a lot of interesting projects. Each one of them has an interesting name. But so, for example, for service discovery, they have something called Eureka, right? They have Hystrix for circuit breaker, and Hystrix dashboard. They have Turbine. They have a whole bunch of technologies, right? And over time, Spring decided to adopt a number of these technologies. So, for example, Spring usually doesn't provide implementation. Spring usually provides a declarative method where you can declare you want to do something, and then under the cover, Spring could use this implementation or this. So it's basically programmed to interface, right? So and then hides away all the implementation details of that particular area, right? So then Spring Cloud Services was born out of this. Spring Cloud Services is really a layer of indirection and interface on top of Netflix OSS. And some other technologies. It's not just Netflix OSS. So let's talk a little bit about service discovery and see what it is. So imagine that you have, like I said, in my previous company, imagine you have a pricing service. You have an item service, right? And first of all, you have numerous services. Each service, is running at a particular, and then ultimately services are, what are they? They're just basically web applications, right? They're running at a particular IP address and they're running at a particular port number, right? So how can you use a service? You either have to hard code the IP address and the port number of that service in your application, which is a terrible idea. Hard coding is always a bad idea. Or somehow you need a directory service to discover those services. And we prefer a discovery service. Why? Because in a discovery service, you look up by name. Just by knowing the name of the service, you go to one central location, right? It's like a phone book. And say, okay, I'm looking for a service with this name. Give me. And then it's going to return the URL and the port number of that service back to you. And then this is actually a very scalable in infrastructure too. Why is it then scalable? Because oftentimes, even for one service, we can run multiple instances of it. Imagine, it's close to Christmas, and suddenly, your sale, becomes 10 times more. Or today is, I don't know, Black Friday. And Black Friday, a lot of people go do online, shopping, right? So now previously, 3 servers was enough, to cover for your full load of 1 million customers per day. Now you have 10 million customers a day. So you need 30 servers, right? So then instead of just these, 3, you have 30, right? So all those services can register with console, and any application that needs those services go to console, and console can basically distribute the load evenly among all those services. See? So there is a lot of advantage to service discovery. You not only, you organize your whole environment into a single directory, but also it also acts as a load balancer for you, right? This is not the only way you can do load balancing. There are hardware, firmware, appliance load balancers such as F5, but this is also one way that can help with load balancing. And it can have very complex algorithms for load balancing. The simplest one is round robin. First request that comes in gets the first node. Second request that comes in gets the second node. Third request that comes in gets the third node. But ultimately, you can go back, and then have even more complex algorithms for that. The architectural design pattern that I want to mention here is a circuit breaker. Here you have a state machine. This is a state machine representation of the circuit breaker. The circuit normally is closed. Closed means, traffic is flowing, like the bridge is closed. So closed actually means open, means the traffic is actually flowing. In a circuit breaker, right, electricity flows only when the circuit is closed, right? Because if the circuit is open, then you stop the traffic. So closed actually means green, means good. So if a request comes in and succeeds, then the circuit stays closed, and then you continue in this loop. But if requests come in and it starts failing, it starts counting them. And as long as, maybe once in a while you have a failure, it's okay, it tolerates that, you still go back to closed. But if you get to a point, a threshold, where let's say out of every 1,000 requests, 100 of them are failing, you have the 10% failure, that's not good. So then you open the circuit. And when you open the circuit is that you're saying, okay, there's a major failure in this part of the system. So I'm basically decommissioning this part of the system. I'm taking it out of service, okay? So that, applications, well, first of all, users who are using that server are going to get an error message, right? So that's not a good thing. And the other thing about circuit breaker is fast failing. So as soon as somebody requests that resource, you immediately respond with a very super quick error message. That, okay, this is not working, or maybe you have some default behavior. And then after a while, if things, go back to normal, then, you start maybe running a few requests, and if those requests succeed, then you return the circuit back to, fully operational and fully functional. The other thing, this is actually not source control management. I think I made a mistake of titling it that way. This is a Spring Cloud config, okay? And a Spring Cloud config is based on source control management. The Spring Cloud config says, oftentimes your application has configuration, right? And that configuration should be separate from your application. And by separating it from application, first of all, there's a separation of concern, which is a good thing, is always a good design principle. And second of all, some of your configuration may be shared between multiple applications. And the other thing is that you can put your configuration inside a Git repository so that it's version controlled and it's in a proper SCM environment. So that's another thing that is, again, common these days, having your configuration in the cloud, as opposed to having your configuration as a part of your code or having a configuration sitting locally in each node of your JVM or your server. Okay, so having said all the above, if you don't have any questions, I want to show you a demo. Okay? Any questions? No? Okay. So I'm going at a fast pace because we have a limited amount of time, but hopefully you'll pick up some of the stuff that we have here. Okay. So this is really a toy application. It's a Spring Boot application, Let me show you, and it's a Gradle application, so let me see what we have here. I'm trying to find the dependencies. If anybody sees the dependency, please let me know. Yeah. Anyways, this is actually a super simple application. Let me show you what the gist of this application is. This application is basically it's a Spring MVC application. Spring MVC, a Spring Boot application, and when you run it, it calls this Fortune service. Okay, and let's see what's inside the Fortune service. Inside the Fortune service, we have 1, 2, 3, 4. You know, like a fortune cookie, you know, Chinese fortune cookie type of thing, and it basically randomly picks one of them and displays it to the user, right? So if I basically run this application, which is through this, any Spring Boot application, even though it's a web application, runs using a simple main, okay? So if I run this, which actually I think I was running it, but anyways, it's going to restart it. Okay, my application is running. And it's running by default in localhost port 8080. That's the default port for a Spring Boot. So as you can see, it brings up something like that. And if you refresh the page, you get a different code. Each time you refresh the page, you basically get something randomly from that list, right? So it's a super simple application. Now, one of the things that I'm doing here is that I actually have a Git repository for this. So what I can do is that I can go back and forth in the versions, different versions of this application. So this is the basic version, right? And this very basic version is just a starting point. Now I'm going to show you this same application with some added features and functionality, some patterns added to it, okay? So I'm going to go, let me see, where can I jump to? Let me actually do this one. Yeah. So I'm going to jump to a different version of this same application. Okay. And as a matter of fact, I think I may have to go back and fix some of these. So let me fix them for you. It's I'm going to rebuild them, you know, because I changed the source code under the cover, right? So I'm trying to resolve some of the issues. See why I have an issue. And let me stop the server, because the fact that the server is running while I'm changing everything under the cover doesn't help. Okay. So here's what we have done. Previously, we had a monolithic application, right? In a sense, relatively, it was a monolithic application. Everything was running under the same application, right? So you had your, let me show you, you had your greeting service, which was right here, your greeting controller, and your greeting controller was calling a Fortune service, and Fortune service was implemented in the same application. So in a sense, it was a monolithic application. So now what we have done is we have separated the Fortune service into a completely different service, right? And then what we do here we have like a stub. See what this one does. Oh shoot, this one still has, why is it still here? I think we have forgotten to remove it. Let me go back to the controller, see whom it calls. Yeah. See, now it's not calling the fortune service directly, it goes to the fortune service indirectly. And what we are doing is that we basically have the URL of that service, and we use REST template to basically call that service, right? So basically this time, to perform whatever task that was required of the fortune service, we are basically going to a new service. We are calling a service. It's a microservices structure. So let me see where the error messages are. Resolve them very quickly for you. I think the error message is because of this. I can just ignore that for now. It uses Lombok and Eclipse and Lombok to, anyhow, there's some configuration issue. Let me fix that. So that one is now fixed. We also need the fortune service. Let me fix this error message also, which is right there. Okay. Yeah, so our fortune service and our main application, they're both working. Now, if I run my main application now, this is not going to be good. Now, I need to run my fortune service first and then run my main application, because there's a dependency between them. Okay, so I'm going to run this one first. This is the fortune service. And let me actually have a quick look at the configuration. Okay, so you see now the fortune service is running at port 8081. Okay, so let me go back to my thing and show you what, this is a microservice now. Let's see what that microservice does. See, that microservice is now returning, is not returning HTML, it's just returning some JSON. Okay, so it's a get, and then you retrieve some data. In this case, is an extremely simple task, but you can imagine in a real application, you could do something way more complex than this simple task. Now, our greeting obviously is not running. I stopped it, so it's not running yet. So let me go back and run it. So now I run this one. Okay. So now, see? It's basically, actually, because it is random, that can happen. Yeah, okay, it changes. But you see what happens? You say, okay, it's the same functionality. What is the difference? The difference is nothing. The difference is architecture. The difference is previously was one monolithic application. Now it's two services. We have separated, functionality in two different services. Okay? So now, one of the things that we want to do is that we want to have next thing is I'm going to add a circuit breaker to this. And I'm going to show you how the circuit breaker is added. And with the circuit breaker, if the fortune service has a problem, this service, okay, instead of failing, I'm going to return a generic message, just a constant message. See? So that allows the whole system to continue functioning even while parts of it may be decommissioned or non-functional. Okay? Let me go back to my code and see actually what is the next step of the process. I'm going to now jump to a different version of the code again. Yeah. Let's do this. Oh, again, I forgot to close all the applications first, okay. So unfortunately, I have to go back and fix all these error messages very quickly. Okay, there's one more. Oh yeah, well that one I can fix by doing a refresh. Hopefully fixes that, no? Okay, it fixed it. So our fortune service hasn't changed. Our fortune service is exactly the same as what it was before. So if I run my fortune service, the code hasn't changed. It's basically the same thing. And if I run this, I basically every time I'm going to get a random code coming back. Now, my greeting service, I have made some changes, and let me show you what the main change is. The whole magic happens here. This is the circuit breaker. And what it means is, if this method fails for whatever reason, then open the circuit, prevent any future calls to this method, and instead fall back, you see fallback method, fall back to this method. And as you can see, this method is, you see this one is making a web service call. This is a web service call. Here, instead of doing a web service call, we just return something default. So it makes our system fault tolerant, which means that if the web service that we depend on doesn't work properly, then we continue to function with some minimal functionality, some fallback functionality, right? So now let's see. You see that this is the beauty of a Spring, because the Spring is programming to interface. Using just a few annotations, everything suddenly magically starts working. So let's see what's required to enable Hystrix. One is this. The second thing, as you can imagine, we need to do some configuration. So let's go to the configuration file and see what we have done there. So actually, you know what? If you're using all default functionality, if you're not adding any special, configuration for that, but the only thing that we need to do is we need to enable Hystrix, and that would be here. That's just one annotation right there. This basically turns the circuit breaker functionality on. And so basically we have added one annotation here, one annotation here, and then one just fallback method here. That's it. Okay? So let's see how it works. Okay, so now I go back to my application, I refresh. Basically, functionality hasn't changed. Every time I refresh, I'm going to get a new code, right? The beauty of it is, what if this service that I depend on is down? And let me actually bring it down. Let's see. The fortune service, I'm going to stop. Okay, so now fortune service has stopped. It's not running anymore. So I'm going to prove it to you. If I go here and I do this, fortune service is down, right? But I want my greeting service to continue working. So let's see what happens. You see, it falls back to the default behavior. You don't have the fancy behavior that you had before, that every time you called, you would get a new random code from the fortune service. But your enterprise continues to function. See, it's about continuity. It's about the fact that fault tolerance. It's called fault tolerance because your system doesn't go down just because a small part of it doesn't work. Okay, now, so this was circuit breaker. Now let's talk a little bit about service discovery. So let me go back to this here. One of the issues that we have here in this version of the application is we are hard coding to a particular instance of fortune service. So we are hard coding the URL, the IP address, and the port number of the fortune service. What if you want to run two fortune service in parallel, two nodes, right? What if you want to increase it to 10 nodes? What if you want to move it to a different service? Now the IP address changes. That's horrible, horrible design. The IP address of your application changes. You have to go back and make a code change. See, because this is inside your code. It's hard-coded inside your code. So this is a terrible design. To fix this, we do service registry. In this case, Eureka is the platform. So let me now again magically jump to a different version of this application. I'm sorry, was there a question? What's that? Oh, thank you. Thank you so much for remembering. Yeah. Okay, so I'm going to go back to here, which is basically the finish point of Eureka. Okay. So now I need to go back and again fix all the compile time errors, those annoying log files. Oh boy, how many of them do we have? Those are okay. They're going to be solved after I recompile. Recompile is going to solve them. Okay, this one I need to fix. Okay, I think that's it. Yeah. So, and then here we have a few things. No, this is okay. And then now we have a new project called Eureka. Let me refresh these. Should be there. Okay, so let me just select all of these and rebuild them. Okay. I'm actually still surprised that this one doesn't build. I think at this point I should have the, yeah. Okay. Let me build it one more time. Anyways, so let's focus on the other one. So in this version, we still have two services. Greeting service depends on Fortune service, and we have the same architecture, except that if we look at the configuration file, you see here you don't see any dependency on the Fortune service. There is no hard-coded URL, port number, etc. Now, let me go inside the code and see exactly how we are doing the lookup. So if you go to inside the Fortune service client, which is basically the part that invokes that microservice, you'll see that, see, this is a Eureka client now. Eureka is service discovery in a Spring Cloud Services. And what we are doing here is that every time you need to get the Fortune cookie, every single time, we do a lookup. You see, we basically are looking up, in the, and if you look at the lookup, this is just a method here. It goes to the Eureka client and gets the next server from Eureka. And this is based on app name. Where do we see? App name is Fortune. Okay? So as long as, so how does it know, based on name? That name is also defined in here. So that name is the only link between the two. So you see, name is better than value. Name is better than the IP address and the port number, because name doesn't change. Port number and IP address do change over time, right? So, and that name, just so that you know, is defined here. See, it's that name, Spring application name. Every Spring application has a unique name in this, microservices architecture, and it's going to be registered based on this name. Now, there are a few things that you need to do, obviously. So one of the things that you need to do for your application to register in the registry is this. Enable Discovery Client. Again, everything is magic. Everything is just, annotations. Using annotations, magically everything happens. And then inside here, I think we also have the same thing. Yeah, here we have now circuit breaker and service discovery. And then the whole magic of discovery happens here. You have the Eureka client, and using Eureka, we do a lookup, and then we call the service. Okay? Now, let me see. Let's run the whole thing again. You see, right now nothing is running, right? I'm going to run the greeting app first. And you see how fast it loads? The Spring Boot is doing a good job of. Oh, there was an exception. What is that exception? Oy, oy, oy. Oh, because I think my Eureka server is down. Yeah, I should run Eureka. But my Eureka has a problem. What is the problem with your Eureka? Yeah. Okay. Even though it shows the exclamation mark, I was still able to run the Eureka server. And let me actually see where my Eureka server is running. Okay, my Eureka server is running here. So you see, this Eureka server is your console, is your service discovery place, okay? And just like anything else, it's also a web application, has a web interface, and you can look at it through the web application. Oh. Okay. It seems that the gods of demo are not cooperating with me. For this last part, we were successfully demoing everything up to this point. Let me see what is running and what is not. Okay, Eureka server is running. There's no exceptions. Everything looks okay. But here we have a problem. Why? Yeah, okay. For whatever reason, that was not working. So this is my Eureka server, right? So yeah, somehow it knows that the greeting app is down. So now let me go back and run the greeting app. Now, as soon as the greeting app loads, it is going to go and register itself with Eureka. Okay, so now this time we didn't get any exceptions, right? So now if I refresh this page, see, now greeting app is up and running. Okay, now, and the proof of it is this, if I run it, it just runs fine. Even though my Fortune service is still not running, see, it still is down, I haven't started it yet. But this one is running through the circuit breaker. Because the circuit is open, it goes to the default behavior. Now, I am going to run the Fortune service too. And at that point, the Fortune service is going to register with the service registry. I can't remember if I have to restart my greeting service for that or not. I have a feeling that I may not even need to. Yeah. So now if I go back to my service registry, see, Fortune service is registered here too. So you see, it's a central registry. Any microservice in your organization is going to be listed here. And then obviously your Fortune service is running. And now if you go back to your, I think part of it could be the circuit is still open. Even though the Fortune service is there, but the circuit here is open. And one way, well, I think the timeout is about 1 minute. We could either wait for 1 minute, or in this case, I'm going to restart this so that it makes it faster. I'm going to stop this and restart the greeting app. Then go back. And by the way, this is the end of our demo. In just a couple of minutes, I'm going to wrap up. Okay, so let's first go to Eureka, see who is there. Yeah, everybody's there. My Fortune service is up and running. My greeting service, voila, everything is working. Okay, so this basically ends our discussion for today. My goal was to give you a very, very brief overview of what enterprise architecture is about. So I showed you how to design a large-scale system. Some good practices, CI/CD, continuous integration, continuous deployment. We looked at the use of source control management, automated build, automated deployment, automated integration testing, and then we looked at some Spring Cloud services and some technologies and an enterprise architectural design patterns that are out there in the market and are implemented by these frameworks. Spring Cloud Services is a framework that uses those. And I showed you service registry, I showed you circuit breaker, and as you can imagine, this is just the beginning. This was just a demo. This was just a small sampling of the vast world of technology that is out there. But I just wanted to pique your interest and then show you just a taste, just a small taste of what enterprise software development looks like for a real-world company and a real-world application. That's all.